This conference will now be recorded.
It's time to start. Good morning. Uh, Welcome to Eastern North Finland High Impact Action final seminar. Today's language will be English, as we're expecting European Commission and a couple other English-speaking colleagues to be on board. But I guess we're all used to it already since the beginning. First of all, as you heard, this will be recorded. There are many interested colleagues who would like to listen this afterward who couldn't join today. I will be the chairperson. My name is Ilari Havukainen. Most of you must know me already. And a few things about the program for today. Before I give the floor to Päivi, we would like to focus on a few things in the program. First of all, we will have a European Commission giving their reflections about the whole industrial transition pilot process. And then we will move to the projects itself, and we reserve 10 minutes for each project. And if you think there will be good to leave some time for the questions and discussion, I ask you to limit it to 7 to 8 minutes. But I'm sure that we will find some time to discuss about the results and the whole process at some point. I'll take care of that. And after the 4 projects, we'll have a short break so we can all refresh and take a cup of coffee before continuing and finishing with the rest of the projects. After that, we will get some comments from European Commission for the results of the projects, and then evaluators' perspective from Vincent, who was the chair of the evaluating committee. Then Mika Riivi from Regional Council of Lapland as a county governor will finish the meeting. And that's about 2.5 hours from starting. Do we have Päivi on the line?
Yes, I'm here.
Yes, thanks. So I think it's a good time to start now, and the floor is yours. I will switch my camera and mic off here.
Okay, thank you, Ilari, and hello everyone, and good morning. Good morning from Rovaniemi. I was just calculating or thinking my calendar, last year's calendar, and thinking that it was actually just 1 year ago when we were able to open the call for these pilot projects. It was in September, beginning of September. And in that phase, of course, we didn't know what to expect to happen during the coming year. And we were lucky not to understand and not to know anything that will happen. And now we are in totally different situation, of course, than what we expected a year ago. But nevertheless, I think that what we have heard, we have had these seminars with the pilots, and we have heard good midterm reports and results already during the whole process. So we have been very happy to notice that that the activities have been ongoing all the time, despite of all the hampering things outside of the offices and in the whole Europe and in the world. So today I'm very eager to hear the final results of the pilots, of the processes, and for you, all the pilots, I can also say very warm and big thanks, because your work, it has shown that this kind of instrument has been very important and it has been needed. And now here has been a possibility to test all the new kind of things to implement, and new ways to implement things in East and North Finland. You must know also that the drafting of the new structural funds program in Finland, the national program, is actually already in its last details, and it has been going on all through this year also, when these pilots have been implemented. We have been able to take some experiences from the pilots and seen the comments and the results, and we are trying still to use them for the benefit of the new financing instrument, this financing program. Quite many changes to the program did occur in the last meters, because there were some changes from the Commission side during summer on these comments to the Finnish Structural Funds program draft. And also I think that the MFF and the Just Transition Fund and all the recovery program and everything that has occurred during the summer and has been taken forward during the summer, they have made some justification. But anyway, I think that when the program document will be ready for comments and for the public hearing processes, you will see that there is a strong emphasis on enterprises, strong emphasis on digitalization, of course on greener Europe, and or the Green Deal. Of course, it takes a big space from the program implementation. But then the time of that public consultation will start about in the beginning of November. That was the assumption now at the moment, but let's see when it will happen. But today we will hear about the results, and we will gather them still to our pockets in order to use them in the finalization process with our ministry and the regions. So, well, I think that this is all the time I want to take from the pilots and from the other experts that will be speaking today. I'm happy that we have not only the pilots participating, but also the regional participants now today. So I will be listening also all through the day, and maybe also commenting something or asking something. So I hope fruitful discussions and all the results, and I hope that we will also have some news from the European Commission, maybe from the views for the future. So on my behalf, wish you a very fruitful discussion and good final seminar. Okay, thank you.
Thank you very much, Päivi. I'm seeing that we don't have Peter from the European Commission on the line yet. I just sent a message him to double check that he is able to join. At least we have Vincent on the line. Another way to do is that if Peter is not yet here, we could start to go to the project itself. Yes, I think I can't see Peter. or Dennis either. They haven't been able to join yet for some reason. Maybe we move to the projects and give the floor to Peter at a suitable point. Sorry about the confusion. First in line, we have the Universal Digital Tools for Forest Machines Uniforma project, and it's from the EMPK company. I see that we have Tutti on the line from EMPK. Tutti, can you hear us?
Yes, we can.
Okay.
Hello, everyone.
Hello, do you want to take over the screen as well?
Sure.
You can see us.
Thank you very much. Can you see us okay? How is everyone doing?
You're in your screen. Share your screen. Yes. Okay. Siitä vaan. Yeah.
There
Share.
we go. And on to Glory. There we go. Okay. So, good morning to everyone from me and Mikko Saari. We're going to talk about the Uniforma project and what the final results of it are, as we are in September 2020. It's been quite a year, as we know. Just to recap, the problem and the solution we were aiming to solve in this project had to do with poor communication and information transfer between forest machines, firstly. Also, there were almost no tools for work planning in forest machine work. And all the hardware, most of the software as well, was quite old. And the Uniforma solution that we aimed for was to find a safe information transfer and work planning tool that was developed for all forest machine fleets, built from the viewpoint of forest machine operator. The solution predicts the best solution for forwarding work, and also it creates a ton of data from the forest that can be accessed for research purposes. And during the first phase, which was approximately for us from March to May, the software design and development was in the center of action. So a solution that we found was workable for collecting positioning data. Also, we converted harvesting data to an anonymized format, and an algorithm was tested for calculating different product types in forwarding loads. And we used real worksite data to test the solution at this phase. And then in the second phase, from May to July, the Uniforma solution was tested in a relevant environment, in other words, in the forest. And we tested collecting the positioning data, and we managed to successfully convert harvesting data into a suitable format. We also found that transfer tests of the anonymized data showed a 50% improvement on transfer speed and up to 95% or even more of a decrease to the file size that needs to be transferred compared to the normal harvesting data, which is quite a big improvement. The algorithm for calculating different product types was used to create an estimate for the forwarding loads on a real work site, and then the work site was cleared and the results were collected and compared with the estimate. And now I'm gonna hand over to Mikko, and he's gonna tell you what we found during these last final test phases.
Okay, hello everybody. What we found was that all the key elements of the Uniforma solution worked in real life. That's cool. And it's possible to create an estimate of loads and product types in a worksite using the Uniforma algorithm. This was what we really wanted to know. And the estimate calculation needs for further adjustments for accuracy on the total number of loads. And two possible calculation methods were identified. One was tested because we found one more, and we don't know yet if it's better, but we found it. So, and the estimate already gives accurate results on the ratio of different product types on a work site. And this is a valuable information for the operator itself. And further testing is needed for a ready product, but the project was a great success. We really didn't have much testing on this because of the COVID and because of the current situation of forest machines in Finland, forest machine business in Finland. But anyway, this is physical prototype of the Uniforma solution. We use this to collect the data from harvester, and so you can simply put it into a harvester and it collects the information and converts it. And if we have time, I'm going to show you a brief video about this solution. I believe we have time to do this.
Yes, we have time.
All right. Can you see this?
Yes, so far we can see.
Yeah. All right. I think it's still loading, but
Sanotaan, että metsäkoneet tuottavat nykyään paljon tietoa metsistä. Kuinka helppoa tämän tiedon hyödyntäminen oikeasti on metsäkoneen kuljettajalle? Uniforma on ELMO-rahoituksen avulla tuotettu pilotti, joka tähtää metsäkonetyön tehostamiseen ja sitä kautta päästöjen vähentämiseen ja koneketjun kannattavuuden parantamiseen konkreettisilla työkaluilla. Aika vaikeasti selitetty vai mitä? Näytän, niin innostut. Ajatellaan hakkuukonetta, joka tuottaa eri puutavaralajeja metsään pieniin nippuihin. Kone tuottaa kulkiessaan sijaintidataa, jonka avulla nähdään työn eteneminen. Puutavaran sijainti on tiedossa ja nähtävissä kartalla. Tämän verran tiedetäänkin jo, ja tämä on tuttua. Uniforma vie ajatuksen pykälällä eteenpäin. Se laskee ja muodostaa kerätyn tiedon perusteella kuormatraktorille kuormat jo etukäteen ennen työn aloittamista. Kapasiteettiin tehdyt muutokset voidaan ottaa helposti huomioon. Uniforman avulla tiedät, milloin kuormaus kannattaa aloittaa ja kuinka monta kuormaa työmaalla on. Järjestelmä toimii kaikissa kuormatraktoreissa merkistä ja mallista riippumatta ja on helposti asennettavissa hakkuukoneisiin. Katso lisää EMPK:n verkkosivuilta.
just a quick spoiler here. We haven't yet updated our web page to contain this information, but anyway, it's coming there pretty soon. And I think next slide is the last. Okay, in the summary, we are now able to collect data from harvesting machines and transfer and anonymize it and calculate the ratios of product types and forwarding loads and create forwarding load estimates based on the collected location data. And we have been testing this on the reliable environment, and this is very much viable for further development, we must say. I would like to show you quickly, if I can put the camera on. How does this work? Stop sharing, yes. All right. Now you can see me in the camera, I think. So I think I just want to show you this, if it works. So it's in my hand now, this prototype. So it's a concrete thing. now, and it's amazing that we actually made it and you made it possible. So we are really happy.
Sorry, we can't. At least I can't see the camera on at the moment. So.
Okay. Wait a second. Share. Yes. Is it now?
Now it's on. Yes.
All right. Okay. Great. So let me show you again. Again, this is a concrete solution. So this is what we use to collect data from the harvester itself. So it's kind of cool. This is all because of you. So thank you for that.
Yes, thank you so very much for listening. And it's really been a great year, and we want to thank you, everyone who has been involved in the project. Thank you very much.
Thank you to them, Mikko. Great to hear your story and a very nice video you compiled. So it's nice to share that onwards, and there will be multiple possibilities to use that as well. Then we can move forward. I just got a message that the European Commission is soon getting on the line. So let's take one more presentation.
Ilari, I'm sorry to interrupt, but can I ask one question?
Okay, yes.
Yes.
Of course.
Yeah.
Of course.
Yeah, sorry. But it was very interesting to hear your result, and I was very happy to hear that you have succeeded so well in your project, because I remember well when we started and we had in December this first session, and you were so excited of this whole project and plan, and now we can see that it was a success. Do you have thoughts for next steps? Do you have ideas how you would like to maybe to continue from this?
Well, there's like 5 different thoughts, but first of all, I must say that there might be some person in this group that I'm going to contact later on, and I believe he or she knows who I'm talking about. But yes, I think, well, from business-wise, it's complicated situation in the forest business currently, because we've been like when we've been like doing this project, we also find really much details about. We got into the depth of this forest machine business in Finland and in the northern countries, and from business wise, it's something that must be really carefully thought. But this is a kind of cool project in any way, so it would be shame to just leave it where it is. But obviously, we try to get it forward. But we'll see if we see if we find a way how to put this on the field. Hopefully we can. I must share you a quick story. I have like 2 minutes. So when we test this, and forest machine operators are generally really not really social guys. So we went to the forest and we had this operator who was not familiar for us, and he was like, "No, I'm not going to do this. This is no way. I'm not going to do this." We just wanted him to put the cargoes on a paper, that how many cargoes he'd been doing. And on the next day, when he heard what we were doing, on the next day, this guy called for the harvester operator and asked him like how many cargoes there are. Can you tell us, please? Like, can you not? Well, give us the solution. And we were like,
he was really hungry for the data.
So we were really happy. And this guy was like close to 60. So he was old. And it's not about like the young people are familiar with the computers and stuff like that. No, it's more about usability. And that's the key here. And that's what we must think about in the future. But yeah, Päivi, I would be really happy to talk more about this, but we have to move forward, I think.
Yes.
I keep on talking.
Thank you. We can come back to this, but thank you. This was already a good information. Thanks and good luck.
Thank you.
Thank you.
Terry?
Yes, you have a comment?
Yes, just a comment, if you remember me, dear colleagues, I was the evaluator, chairing the evaluation panel, and I'm very happy to hear you all and to be here and to see the results of this project. It's very encouraging, very interesting. You must know also that some of the regions followed your example, like Wallonia in Belgium, for instance, implemented a very similar mechanism. but more in the field of bioplastics. But it's the very same philosophy. So you are basically pioneering with all those projects. A question for Uniforma, maybe the key point, and that's maybe something the others also have to think about. And what is the next step? And that's most important for us. And we have no doubt that you did a great job and that you progressed. But then the big thing now is, okay, how do we push it further so that we have in the future very nice innovations that can be brought and sold on the market? And then I think that for Uniforma here, if you speak about further testing, there is of course the communication issue. You need to communicate and to make things more visible to more companies. But I think there are two key issues here for the further testing. The first one is interoperability. To what extent can you guarantee interoperability between different systems and forest machines? Is that already the case or not? And if not, how do you plan to guarantee interoperability between different types of forest machines and systems? And the second point is the vertical integration. Your system is increasing, optimizing production, but to what extent does that have an impact on the whole production chain? That means, do they need to have additional carriers ready to go at some point? What does that mean for the whole production chain when you add the Uniforma solution to the production chain? These were my two questions. So interoperability and vertical integration in the whole production chain.
Thank you very much, Vincent.
Yeah. Okay. I was also it was so great to hear from Vincent actually because if I'm quickly may say about this interoperability. Yes, this is actually something that we really took thought about when we started this, because we know that there are similar few forest machine builders who are building different software versions for different machines, and it's a mess, to be honest. So we wanted to look really the simplest way to connect stuff, and we thought in a way of how this operator himself or herself would connect this into the machine. And we wanted to make this really simple. And yes, that's a really good point that we really need to because we need to test this, because so far we only know that there are certain file types which are supported on this system, and it's not yet really common on the field, but I hope that in the near future it will be. So this is we are probably looking a little bit on the future here. And yeah, and about this vertical integration, I think if I may send you an email, Vincent, about this, if it would be okay, because I'm really worried if this takes a lot of time to explain. So, but that's a good point. Let's put it that way. We've been thinking about it a lot lately.
No, okay. No, please do. My inbox is yours.
Okay, thank you.
Thank you very much. I think it's time to move on. Thanks for the interesting presentation, EMBK, and thanks, Vincent, for the comments. I see we have Dennis on the line from the European Commission now. There was a slight confusion with the time zones, and I think it's mainly my fault. But as we speak, we have Dennis on. Do you hear us now? You have your mic off at the moment.
Hi,
No.
Good morning. Good morning. I'm sorry for being late. It's actually, I believed it was at 9, and it's a 1 hour difference that made a difference. I don't know whether Peter is around as well.
Oh, we haven't seen him yet?
You haven't seen him. I think this is we have it in our calendars as for 9 o'clock, and I think it would be good if Peter could give you the really the how to say
So we can
the main messages, because I'll just give me a second. I'll just get to him, and I'll stay the whole morning with you. I mean, it's a pleasure to be with you. It's always pleasure to see the progress of the action. And when I was looking at what you've done and yesterday and what is there, it's really an exemplary action. And we discussed with someone yesterday that the whole industrial transition pilot was so ahead of its time, because when we started talking about industrial transition, twin transition, now it's the main, I mean, economic policy, I mean, the green and twin transition for the EU, I mean, at the level of presidency of the Commission. So I think we were a bit experimental, and I'm happy to see that it functions in Finland and other regions. I'll try to catch Peter in the meantime, and sorry for this misunderstanding on our side.
Thank you very much, no worries. We can move on now with the presentations, and I think we have the Wood Heat and SF Tech. We have Virpi Leinonen on the line.
Good morning, everybody.
Good morning. I give you the presentation rights, so you can go on with the presentation from your own computer. The floor is yours.
Thank you. Maybe now you can see my presentation. Okay, so Wood Heat project, increasing value of forest wood biomass. And my name is Virpi Leinonen, and I was a project manager of the project, and also our partners are listed here in the bottom of the slide. So we were cooperating with Biomeca Oy, Lapland University of Applied Science, Sulkala, and also KK Module. And our aim in our project was to valorize and enable wood forest industry materials, and specifically increase the caloric value of the material by drying, and so bring the direct benefits of wood-based materials to power plants and in energy use in smaller power plants, for example, for the end users of the production chain. So basically what our project included was three main things: was the building up the piloting facilities, and also some initial mechanical changes to the product itself, the mod heat dryer, and then was the artificial drying and the piloting campaign, during which we were evaluating the energy efficiency, capacity, and operational expenses of the processing, and this is related to drying itself. And also we made some technical and economical feasibility analysis, how the drying is and how much it costs when it's enabled or implemented to the energy wood production value chain. And to accomplish these results, we started with the building up the testing facilities, and we designed the layout, and we designed some changes also to the dryer itself. The dryer is seen the blue container in this picture. So the piloting environment itself was located in nearby the heating plant of Biomeca Oy. So we got the energy for drying from the local small heat plant through heat exchangers. So we used the reserve heat or waste heat from the heating plant to heat the air to dry the materials. And the tested materials during the test campaigns were wood chips and bark. And during the campaign, we made some test with the materials, and also made some mechanical changes and development to the dryer itself. And here's another perspective from the test site. So you can see that we had the connection straight from the heating plant with the heat exchangers, and water circulation comes from the heat plant nearby, and we was able to use that straight during the test campaign. And about the testing and related to that, we also improved our measurement systems and implemented some new measurement point to evaluate the results and efficiency. So we need to have data from the process to be able to evaluate the efficiency of drying and so we made some new instrumentation together with the Lapland University of Applied Science. We were able to measure, for example, temperatures and relative humidity of the air inlet and outlet, and some energy values from used energy and so on. So some new instrumentation was also included. And piloting itself, we started with the drying of bark, and it showed its nature. So it was very challenging material for drying because of the mechanical mobility was limited for this kind of material. We were aware of that we might have some difficulties with bark, and as we had tested it earlier and we made some preparations for related to that, we, for example, crushed the material 2 times to avoid more or bigger or long parts of the material to be packed or stuck in the dryer, because we are mechanically moving the material inside the dryer. Even though we try to make it easier to handle, we had lots of difficulties and stoppages in the production because of the material. And that also affected the dryer's efficiency. So the efficiency was rather bad from the production point of view. So that if in production scale we would dry the bark, it would be not that reasonable with these efficiency figures we gained during this test campaign. So we didn't get like a good evaluation of the dryer's efficiency for the bark at this case. And also the capacity was quite low because of the troubles with the mechanical movability of the material. But in any case, we learned a lot, and we have solutions and development ideas for the design and how go for it with the bark, because the bark will be and is being asked from the customers. For example, big forest companies are asking solutions also for drying of bark, but we will continue that work. The other case was wood chips, and for wood chips the drying was much more easier, and the material was more even quality, so we got better results and were able to more easily to handle it. So we start with the starting humidity of the material in average was around 50. There was some patches that were more drier, and the aim or final humidity of the material was around 30% of moisture, which is a quite good level for the small heating plants to handle, and they are aiming to from 25 to 30% of humidity and even quality. The heat that we had available and the energy for drying was around 230 kilowatt hours per kilowatt hours energy, and the capacity of the dryer was around 3 or a little bit more. And we were able to evaluate the efficiency of dryer, which was a little bit less than average, a little bit less than 1 kilowatt per evaporated kilo of water. So it's in quite good level in compared to the competitors, for example, drum dryers and belt dryers. And some cost evaluation is done also during this based on these campaigns, and the heat price and the electricity price are shown in below of the below of the table, so that we use this kind of average values, evaluate the energy cost of drying, and the value increase of the material was around euro, a little bit over or less, and the value increase of the material is just based on the energy value increase, which is done by the drying the material from higher moisture content to lower moisture content. So just that is calculated for this. And in general way, we can represent the benefits of drying as a part of the energy wood supply chain, so that if we have wet wood chips, the load sales value based on the energy value is something. If we are able to dry it, we are able to increase the value of the load, and also increase the material value transport after drying, so we can save some logistical costs also. But of course, there's a price for drying also, and the key issue is the energy costs related to drying. So in all over, we can see that the drying is quite expensive, and based on only the increased energy value of the material, and not evaluating any additional value benefits from the drying, we can see that only the energy value increase don't cover the cost of the drying with these kind of prices, energy prices calculated in this case. But there's also possibilities to improve the profitability. We see that the capacity could be increased by optimizing the process. We have possibilities to improve also the energy efficiency in the future if we can get the more continuous process, and also we have still possibilities to, for example, improve the energy efficiency by recovering the energy from the exhaust gases, for example, and so on. And also the energy efficiency is related to energy availability, how much energy we have available. In this case, we were a little bit limited because we had the heat exchanger on top of the dryer so that we can utilize the district heating water from the power plant. But unfortunately, we had the double heat exchanger, but the other heat exchanger was broken, so we was limited with the energy in this test campaign. Also, we could optimize, and we need to optimize the rate of drying, so that how moist material to how low moist content we are aiming. So there's no point to dry material from 55 moisture content to, for example, 15%. That's not necessary from the energy production point of view. It's not efficient from way of using. So there's an optimum for that also. And the operational cost of drying are now just evaluation, as we don't have that much reference data for example, about the manufacturing cost and preparing costs in long run. And the key issue is the energy price, the thermal energy price, which is the actual price of the thermal energy if we are able to use, for example, some kind of waste heats, how the price is evaluated. And also we will continue evaluation of the additional profits in the energy wood supply chain. And as an example in this, this is the very general and simplified road of energy wood supply chain. So if we add drying to this supply chain, we are able to use the reserve heat from the heat production. For example, during the summer times, the small heat plants are not able to run the heat plants with wood or bioenergy based materials because the load of the heat plant is too small. So they need to use oil for that. And in our case, we were able to use that energy for drying and during the summer months, so the heat plant didn't need to use the oil to warm up or keep up the plant as the sales of the energy is less during the summertime. And by drying, we might also get rid of the roadside storage, and we are able to respond to fluctuation of demand during the different times of year, and so also speed up the material circulation. And if we are able to skip the roadside storage time, the time of savings will be huge. If we talk about that normal natural drying of wood on roadside takes several months. So now after harvest, the material would be transported, for example, after a week or two to the shipping and so on. Also, some other additional changes or savings could be achieved by excluding the roadside storage from the process. And also, I think the main benefits are gained from the heat production itself. If small heat plants are getting more homogeneous, better raw materials, there's less of disturbance and maintenance costs. For example, we got the initial comment from the heat plant that they are able to save like 2 to 4 euros per produced megawatt based on the maintenance cost if they have good raw materials, especially in the winter time available. So mainly the maintenance costs are based on the poor material or too wet materials. So some savings are able to occur also during the whole production chain. But the difficulty is that if we calculate the profitability of the wood chip of drying, in this case we calculated two examples with different capacities with same invest. The operational cost varies based on the humidity, how much we are drying the material, and there's some initial ideas how much energy is needed. But the main key issue is that the payback time shows that there's a potential to include the drying as part of the energy wood supply chain. But this payback time calculated here is evaluated based on all the benefits for the whole production chain. So now as the production chain is divided with different companies and different kind of operators and such, so the benefits are divided in different parts of the chain. So it's quite hard to evaluate straight who gets the most benefits where and why and how. So that's the reason why in this case and after this project we will continue that work to evaluate how the benefits can be divided and what kind of business model we could use to implement the drying as part of the project chain or the energy wood product chain. And this work we will continue with. We have started discussion one municipality that has small heating plants that and they are interested about implementing the drying as part of their processes. And so we are starting the discussions, and now we are going to make an next project with the municipality and our financiers to evaluate the details about the benefits of drying as a part of the whole chain and how we can make it business out of it, and how can we divide the benefits so that all the participants in the chain and beneficiaries are getting their part. And so that's generally our part, and thanks from my behalf and SFTech behalf, and also from to all our cooperators and the financiers about this interesting project and possibility to test things and develop technology. Thank you.
Thank you very much, Virpi. Happy to have you on board. We have short time for comment. I saw Gitte has wrote a question there. Do you want to ask it? And then I give for Vincent as well.
Yes, I have a comment and a question.
Sorry, Vincent, can we go first? Gitte had mentioned something on the chat, so I gave floor her first, and then you.
Oh yes, sure.
Hello. I have one question to Virpi. I have a history in the manufacturing industry myself, and we noticed we were also trying things, and we noticed a clear difference between doing the trying during the winter time when the outside air is very dry, and also during the summertime when it's quite humid. So are you planning to repeat these calculations during the winter time when the outside air is not actually disturbing so much, or the moisture in the outside air is not disturbing so much of the process?
Yeah, we are able to evaluate and we can calculate it also for that. But I think in this case, as we had even though we take the air straight from the atmosphere, but we have the heat exchangers, so it was the humidity of the air going inside the dryer was quite even. But of course, it relates to the energy needed to heat up it. So it's, there's a little difference. We have been making evaluation related to that, but we didn't bring it up in this results yet. Yes, but it will affect. Yes, of course.
Yeah. Okay. Thanks.
Now that's on.
Well, thank you very much for that presentation. I'm very impressed, Virpi. This is really excellent work. Of course, not everything did work. I mean, the results were a bit deceiving for bark drying, for instance, as I understood. But the analysis, I think the analysis is very sound. And actually, for wood chips, you are not far from the break-even point. If I look at your calculations. So I think it is very encouraging for the future, and I really have to congratulate you for the very good work. This is really what we wanted to support, this kind of testing, piloting activities, and doing some sound feasibility analysis, economic and technical. So it's really excellent. And I think you defined the next steps very well. I mean, what you have now is if you think about using part of the dried wood chips for heat production, then it is all about scalability. It is all about bundling streams and quantities, volumes of wood chips to have it at a cost effectiveness right level. So what you plan to do with a municipality, for instance, is a very logical next step, and it's very good. And I was just thinking maybe it is, well, at least in a few regions that I know also, it would be a very suited project for ERDF money, for instance, or for structural funds. So maybe you can get support also not only from municipality and the private sector, but also from other levels in Finland. But really, congratulations! This is really amazing, and you progressed. I think you progressed a lot.
Thank you very much, and it's nice to get this opportunity to test. And now we have some evaluated numbers to convince the next steps progress, and with these numbers we were able to convince the municipality to be part of the next step.
Thank you very much for both of you. Let's go forward. I heard that Peter will join in let's say 10 minutes. He's be on the line. So we can squeeze in one more presentation from project side. We have plain wood from Southeastern Finland University of Applied Sciences. I think we have Aapo Nylén and Olli Paajanen on the line. Who would like to get the presentation rights? Is it Aapo?
Yeah, is presenting or on my computer, so.
Okay, so I
can try to share my screen. Yes.
Go.
There we go. I think you can see it now.
Yes, very well.
Okay. Good morning, everyone. I'm Olli Paajanen. I'm from the Southeastern Finland University of Applied Sciences, and I have also Aapo Nylén, who is the chief of our unit here with me to answer questions also. So our project was about pine wood in airplanes. And let's see. Yes. So this Atoll plane is to be the first type approved amphibious light aircraft in Europe. And the idea in this project was to provide information for this approval process. And what's special about Atoll aircraft is that it's the only manufacturer in Finland and the only one that has planes built out of wood in this class of aircraft. And why they use wood? So the main reason is that its technical properties are good. It's not because of sustainability. Of course, that's a good point, but it's not the main reason. It's a technical solution to use wood. But the wood is lighter, so it gives advantages in the performance of the plane. And wood is corrosion free, it's durable and strong, and it's easy to repair. So it's a good material for airplanes for this reason. And in this project, we had 2 research questions. Can we use an epoxy wood bonded structure in type certified airplanes? And is pine hardwood suitable for aircraft structures? And there were 3 organizations in our consortium: Atoll, and then XAMPP. And we were the lead partner in this project, and our responsibilities were obviously the reporting and etc. But we did basically all the material testing. Atoll provided materials and did some of the manufacturing, or they made half of the specimens for us. And then we had Natural Resources Institute of Finland, Luke Savonlinna unit and they have expertise and equipment for identifying pine hardwood with this UV fluorescence method. So the research plan was to test this epoxy resin system. Does it have good enough adhesion properties? And we would be testing pine hardwood and pine sapwood. And the point is that currently only pine sapwood can be used, and hardwood cannot be used in these structures. So we will be testing that. And additionally, we also tested how does the aircraft grade birch plywood behave with this epoxy resin. And this was like a bonus if we have time and resources to do it. So, and we had and this is relevant because most of the structures are composites of pine and this birch, which is used in joints in the structure. And we used 2 standards in the tests: thin adhesive layer and a thick. So a thick joint and like a close contact type of joint, and we used ASTM standards, which are US, and you can see the test specimens on the right hand side of the screen. And to test how these bonded structures behave, we used 4 different environmental test cycles, and some of them were quite hard. For instance, immersion totally into water and redrying after that. And then Atoll had to find acceptance criteria for these tests. I mean, what kind of results can be accepted? And since there are no or very few type certified airplanes with wooden structures still in production, the standards were quite old, from the 30s and 40s, some from 50s, and some current standard repair standards. But basically these are still valid because the laws of the physics have not been changed, and the wood structures were quite highly developed in the 40s and 50s. They were sort of at their peak at that time. And I think what we have seen after that is the development of chemistry and synthetic adhesives. And into the test results. So basically everything except this test type 3, which was immersion for 24 hours and then redrying after that for Scotch pine sapwood. So that didn't fill the criteria, but this is a very, very difficult test for wood, because especially wood, sapwood swells a lot compared to hardwood. So when the adhesive is very stiff and the wood is swelling, so it creates stresses in the interface between the adhesive and wood. But this is something that has to be researched more into. But in general, I think we got quite good results compared to these criteria that Atoll found for us. And positive thing was also that we got similar results both with specimens prepared at our unit and also at Atoll. So there was no mistakes in the manufacturing process, so to say. And to summarize what we did, so we had to do a literature research. Then we sorted the materials with the help of Luke. You can see those 2 pictures down there. The fluorescence phenomenon is quite visible in those pictures. Then we prepared the test specimens and tested them. And we actually had to make a jig for testing this, for doing these mechanical tests, that we didn't have the right equipment here because it's not very, very common test. So we had to basically make the metal bits that you see here. Actually, yes. And on the 3rd picture, you can see broken specimens of aircraft plywood. And from those, you can see that they have all broken from the interface in the plywood itself, not on the bond line that we have made. So that was quite good result. And additionally, we tested, did some thermomechanical analysis of the properties of this adhesive, because we wanted to see how did it cure properly. And then we found out that it was softer than we expected that the glass transition temperature was lower, which means that it wasn't perhaps hardened completely yet. So we did a series of tests, and we could see that over time this resin hardens. It gains more stiffness over time. So that's something to look into when using this resin. And with this type of epoxies, they have different recipes. Some of them, some of the recipes are quick hardening, and this was quite slow hardening recipe that was used here. That's basically to be able to work with the specimens longer before the resin starts to harden. So that's one thing to consider. What's the correct adhesive mix. And then we did quite a lot of data analysis and report and discussion with Atoll that what they think of the results and so on. So the project outcomes, I would say that on our side, this project was completed successfully. All tests were done according to the research plan, and we did also some additional work, or we were able to do. And Atoll Avion can utilize the results in further activities. We haven't heard from them how is the type certification process is going, but I think from this results side, we don't see any reason why these could not be used in this process. I think this COVID-19 situation has affected Atoll quite a lot, that we had to do a bit more work here at Mikkeli because they didn't have the resources to do all this mechanical testing here that we thought in the beginning, but for us it was not a problem. And to summarize the results, so the adhesion performance of Scots pine hardwood is similar or even better compared to sapwood, and the lower test results of sapwood, they require additional tests to verify the properties. And some more work is also needed to investigate other mechanical properties in this type of structures. But the epoxy adhesive seems promising as used in these joints. And the test results, especially with Scots pine hardwood and birch plywood, meet the criteria mostly. And in general, I think the project was quite interesting and provided useful results and considerations for further research. Especially pine hardwood is interesting material. We could see that it works quite well in a bonded structure because it doesn't swell so much. So there's some potential there maybe to utilize specifically pine hardwood. And since this sorting method works very well, so that could open some new possibilities for wood products industry. And I think from the administrative side, I think we were quite happy that this funding instrument was quite relatively flexible, and the bureaucracy was quite limited, so we could spend our time doing this work. And I think it was good from the industrial point of view as well. So I think we were quite happy with this project and the outcomes as well, and want to thank the funding body for supporting us in this work. Thank you.
Thank you very much, Olli. We have time for one short comment if someone wants to. So then, if not, we can discuss later about the results of this project as well. I see that we have Peter on the line from the European Commission now. Peter, do you hear us?
Yes, good morning. Hi everybody. Apologies for my late arrival.
No worries. I think it's one more good reason to fix the one time zone for European Union. So we tend to get confused still. Do you want to give your intervention at this point, or you rather want to listen more projects?
No, I'd rather listen. I mean, I had understood that you wanted me to give a presentation. Is that correct? Or...
Yes, that's correct. And we can do it now, this point, and then we can move with the break and continue with the rest of the projects. That's totally fine for us. So it's up to you.
Is that, I mean, that doesn't work for you. And I'm sorry, it sort of breaks up a bit the order of the meeting, but
just a bit. We will have a break anyway between the presentations and
I mean, would you prefer me to do it after the break?
Okay, that sounds good. Okay,
either way is whatever's most convenient for you.
Yeah, that sounds perfect. We can take one more project and they can take a break, and then we give the floor for you. So that's how we do.
Okay, perfect.
Okay, next one we have on the line, digitally connected forest operation value chain for ops, and Tuomo Puumalainen from Argonaut company will present. Is Tuomo on the line?
Yes, I'm here.
Okay, I'll make you as a presenter so you can show your slides.
Thank you very much.
Okay, there we go.
Okay, that's good. Wait a sec, I will just move this GoToMeeting window away. Okay, so good morning, everybody. My name is Tuomo Puumalainen. I'm project manager for this high impact action project called ForOps. So about our project. So our project is targeting basically better information sharing in the forest management sector, especially for the small and medium-sized forest management companies. So the project idea was that we will take our existing GIS platform called Argonaut Proms and develop it a little bit further to have these basically technical functionalities that would allow the system to be used as this forest work bank as we described. So this project was done in cooperation between Lapland University of Applied Sciences and then Raja Forest, which is a forest management company operating in Kitee, Northern Karelia. So about our goals. So basically, most of the goals we set for ourselves were these technological improvements to the Proms platform. Basically, we are talking about the information sharing. So we were missing a few of these key functionalities related to the permission control, especially when assigning individual objects within the system, so forest stand or work sites to other contractors, and we were missing those. Then also there was some functionalities that were available on our web platform, but then our web interface, but not in our mobile interface. So those were quite like vital things to have a fluent system that is very easy to use for the end users. So that was mainly it. So technological goal was to have the system usable for pilot stage after this ForOps project. Then we had the Raja Forest, which is a local business or local company here, and they were actually doing the end user testing for these new functionalities and also providing us very valuable information straight from the end users and the point of view of end users from the field, that what is actually needed for this system to be actually operational. So then Lapland University of Applied Science was conducting also a feasibility and market study for this solution and conducted interviews for the target companies, and it was very good information and perfect for this perfect combination, basically this consortium we had. About the activities, basically what we did, all in all, development and everything went very well. First reporting period in January, February, we were focusing basically on the development steps, or more detailed development steps for the technological development. And also Raja Forest was doing these user case stories, which were very helpful for the development team to actually know what end user wants. And of course, we were planning also this study with Lapland UAS a little bit further. And then second reporting period, we actually did most of the technological work. Then also this end user testing, and then Lapland UAS was doing the actual interviews and created the report based on those. So all in all, everything went well. Maybe a few delays in timetable. We plan to have the testing started in March for these most of the functionalities, but actually it was maybe on April that Raja Forest got the access to the functionalities, but basically quite nicely in schedule as well. Okay, the most important slide. So the results. So all goals that we set for the project were achieved and about according to the project plan. So what do we actually have? So I just split this into two different sections here. So we have the technological side and then the business side. So technologically, we have all the functionalities we listed are now available in the PROMS platform and also in the PROMS mobile, and actually already in use by some of our existing production customers. So this was like a very helpful project to have and very useful to us, and also to our existing customers that are working in forest sector. Of course, we have a roadmap and many new ideas for further technological development, and backlog is there. So we will take the list to the next stages when we are continuing to developing the platform and this service further. And most important thing also is business-wise, we now understand much better than each of the medium and or small and medium-sized forestry operators, and basically this market and feasibility study showed that there is definitely interest for this kind of service that we have, and basically it's not ready product yet. We need some product development, and also think quite detailed how the marketing for this service is done and how the contacting of the end users are done. But I think we are on the right track, and we have something here definitely, and we will go further with the idea and try to launch it as a service at some point, definitely. And in the meanwhile, definitely our existing customers are already benefiting. They are using some of these features and functionalities that we described in the project, and they are already in use. So in our point of view, basically this funding and this type of a project was spot on. So cooperation between research organization and basically end user was the perfect combination, and basically was a great experience to us. So thank you very much for Lapin Liitto and also funder and everybody that is been involved with this ELMO project, and would definitely like to see this kind of funding in the future as well. So thank you, and happy to answer any questions you may have.
Thank you very much, Tuomo. Happy to hear that you also succeeded pretty well with your plan and the project. We have a time for a short comment here before we move to the break. I don't see any comments on the chat.
Maybe final comment from me as well. So we had really nice discussion also with the other ELMO projects. So definitely like to see some continuation and cooperation in the future as well. So let's see what happens in the future.
Okay, that's also great to hear that you've been able to discuss with other projects despite the situation is quite abnormal. There is a comment on chat. Vincent, you're welcome. Take part.
Thank you, Hilary. Thank you, Tuomo. Very interesting presentation. We see basically with the first 4 projects that everybody made good progress. But at the same time, you all speak about the next steps, and the next steps are different from the one to the other project. For instance, for wood heat, we are speaking about further scaling up at the level of a municipality, bringing more operators, more actors, bundling streams of wood chips to get effects of scale. In your case, it's a bit different. I think in the case of plain wood, it's also a bit different. I have the impression that in your case, Tuomo, you would be very much helped with another one, a second ELMO kind of support to further test all the properties, and maybe it is also the same for plain wood. Am I right?
Yes, definitely. We would still basically, like I said at the end, the product is not ready yet as a product, so we need to still refine the idea a bit. We have basically some of the pieces developed, and then also like maybe related the next steps could be related more like putting the product together and have a solid plan how to actually get this into the market. So there's like when you are discussing with this small and medium sized forest companies, there's of course like sometimes reluctance that do we want to work together. In some areas it works very nicely and some areas not. So we basically need to think some solutions still to the system that makes it maybe as easy as possible for the end users to take into the use and to test and maybe get the companies on board then more easily.
Yeah. Okay, that's very good. That's I think that's very important for the policy people and for the Finnish authority in East and North Finland, because we are dealing here with different levels of maturity, so they need to think about how to push it further with still different types of instruments. I think that's one of the lessons for me from the first 4 projects. But this is something we can discuss later on. Okay, thank you very much, Tuomo, and good luck for the next steps.
Thank you, Vincent.
Thank you very much. Let's have a break now, and after break we continue with European Commission and Peter Berkowicz's presentation. I would suggest that we squeeze the break for 5 minutes as we are a bit behind the schedule. So let's all meet back here in 5 minutes. Okay, I think it's time to continue, and I think Peter is on the line as well. May I ask you to squeeze your presentation to 15 to 20 minutes so we're left enough time with the last 3 presentations of the projects, and then we have time some time for conclusions. We have a bit more than an hour left at the moment. Peter, do you want to share something from your screen?
Yeah, just wait 1 second.
I will make you the presenter then in that case, and so that I think your presentation will be also about the whole initiative, and then maybe we can hear about something about other countries too and the regions. I think the projects are very eager to learn what's the overall thing they've been involved.
Just 1 second. Sorry.
No worries.
I just need to adjust. Unfortunately, GoToMeeting does not work with the Commission system, so I have to work on a different computer, so it just takes a bit more time.
No worries. We think that is a good system because we can track who's been on board, and we took this before the teams came along in our organization. So
okay, look, I'm just going to have to restart GoToMeeting, so I'll be with you 1 second. Yeah.
Okay. Thanks. Yes, we can see you now. Your mic is off in that new device. Now we see the screen, but we can't hear your voice. I'll make you.
Okay, you should be able to hear me now.
Yes, that's perfect now.
Okay, and you have the screen?
Yes, we do. Excellent. You're welcome.
Okay, thank you. So we can start. So look, I'll be brief because I know you want to leave time for discussion. So I'll go through this quite quickly. I just wanted to give you an overview of where we are with the high impact action and the pilots. We're not at the end yet, but we've done a lot of work and we've learned a lot and we're integrating it, and things have changed as well. So what I just want to do is say a few words on the context of the pilots and then summarize the key lessons of the peer review we did with the OECD. Then a capitalization of the work by the regions who've been working with experts on their strategies, but also on the high impact actions, which are not completed yet, but this is what we've learned so far. And I just want to give you some messages on the next steps. So, I mean, what is interesting is that a great deal has changed since 2017. When we launched the pilot actions. And if anything, it has made the pilot actions more relevant. The first thing is the Green Deal, which becomes essentially the growth strategy for the European Union, with its focus on climate neutrality, circular economy, and for us, the new Just Transition Fund. We've seen the emergence of the industrial policy strategy, and I think this is very relevant to what you have been doing with the focus on strategic value chains, the international trade environment, and most recently, let's say, progress on the EU strategy on critical raw materials, which are becoming more and more of a priority. Of course, we've had the COVID-19 crisis with Next Generation EU, and this means React EU, which is additional resources for cohesion policy, and the new Recovery and Resilience Fund. But underlying all of this is something which is a kind of policy shift, which is that there's a return to regional policy with the discussion on the geography of discontent, but a realization that you cannot just depend on your large urban centers to deliver growth, to deliver jobs, to deliver welfare for your citizens. So it's a changing framework into which we feel very much that the project fits and adds something to. Now, I mean, it's interesting to go back to the original document which launched all of this, which was the reflection paper on globalization and technological change. And I mean, I won't go through the messages, but if you just look at them very briefly, they are even more relevant today than they were 3 years ago. And I think when you asked me to react on the projects, and perhaps I will, but what I wanted to highlight to you is the key question asking the projects from a policy perspective is the last 3 points there. I mean, and whether the projects hit these objectives. And the impression I have already hearing the 2 presentations is that they do. And I think this is interesting because it's a bit of a shift, perhaps compared to 10 years ago, compared with what certainly the EU was promoting in terms of policy. Now, this is reflected as well as regards our new framework for smart specialization, and this fits once again very closely with what we're trying to do with the industrial transition work. We need to broaden the scope of smart specialization innovation, think about not just investment in physical capital, but people, ideas, intellectual property, software, firm level skills, and reinforce governance. And I think that what's been very interesting about the pilot in East-North Finland is a lot of it has been about how do you work together. And I think that's been a very, very interesting dimension of the work, which is important. I'll come back to it in slightly later. So this is just a map of the regions, a better map than our first map. We have East-North Finland almost in the right place. You'll tell me if it's still too far south. But we've had these 12 regions and member states working very, very intensely and working through this rather difficult period. Now, the starting point of the pilot was the strategy building and the analysis and the peer review in the regions. The second part was very much the high impact action, and the idea was to really try and target one particular challenge. It should be something novel, experimental, something which is transferable, something which also looked at how you do things, not just what you want to do. And we saw a broad range of topics. And now we're coming to the end, and I mean, some of them will run into next year. The Swedes are a bit slower than with their project. It's taken a bit longer, so they'll run into next year. And there are 1 or 2 which are also taking a bit more time. But we hope that in the course, perhaps middle of next year, we will be able to round up on all of them. Some are completed by now, so we have to try and think how we will learn the lessons after completion of the pilot actions themselves. Now, the OECD peer review was very, very interesting because the OECD does these things very, very well. And what was interesting from our perspective was that it really was something that came out of the discussions with the regions and helped us to really get a whole lot of messages, which have been synthesized in a kind of framework which we will use in our discussions with member states and regions on the smart specialization strategies. But I just wanted to quickly highlight some of the key messages that came out of this in relation to the main objectives of the action. So the first thing is preparing for jobs of the future. I mean, this is a key policy concern for everybody. And I think one of the messages here were interesting because they gave indications of a need to perhaps reconfigure the provision and the objectives of what we do in terms of training. So better alignment of training policies with firm needs, taking into account digital technologies, and strengthen the links between, let's say, the private sector conception of development, which is very much linked to entrepreneurship, and higher education and vocational training policies. So a reconfiguration there which is needed. The second thing is the need to address bottlenecks to innovation diffusion. And here, this is the message coming out of this is it's very, very concrete. It's about relationships between organizations, between multinational companies and their supply chains, the way in which clusters work and the policies to support them, the role of innovation procurement. And I think that one of the very interesting messages that came out of the discussions was that it's not just about inventing something new. It's also about making sure that you retain capacity that you have and build on what is already there. Managing the energy transition. Here, I mean, this has been very much taken over in the discussion on the just transition, the opportunities which are there, the new types of policy making which are needed, more participatory, and to anticipate the transformation of regional supply chains. Promoting entrepreneurship and private sector engagement. How do we strengthen the role of the private sector within what we're doing in the regions? And then, of course, there's the social dimension. And I think this is one of the biggest challenges which we face, which is how do you make innovation-led growth work for everybody and strengthen social inclusion. And there are a number of actions that need to be taken to bring together what we're doing in terms of innovation, what we're doing in terms of social inclusion, what we're doing with public budgets. Now, that is very much the OECD exercise. We then did a capitalization exercise, and I think Richard Harding and Claire Nowlers spoke to some of you about this. And the key, these were really kind of the messages which were coming out of the strategy building process, which focused on identifying gaps. And one of the key messages was how to build more effective innovation support systems. And this is in terms of the individual actions that need to be taken, but also this overall innovation ecosystem support, because it's the quality of the ecosystem which is the key determinant. As it's important to have strong individual actors, strong companies, strong universities, strong research actors, public authorities taking a leading role. But it's the ecosystem, the interactions which are crucial. There's a need to enhance the smart specialization strategic processes. That's to say the choices, the vision, long-term objective setting. And this means strengthening intelligence at all points in strategy development. That there needs to be a way of understanding how the world is evolving in real time and to adjust the strategy accordingly. One of the key points that came out of the discussions with the regions is that there is a functional geography of industrial transition. That is to say, it's not just the region or the municipality, it's not just the administrative units. You have to actually look at the dynamics of the economic processes and how this works, and find within the smart specialization process a multi-level governance framework that can deal with this. And this means probably, and I think it's the key lesson for us, that we need to be a little bit more flexible about how we think about strategies in the future. So here are some key conclusions that came out of the capitalization exercise, and I think they're useful points. The first point is a fundamental one, and it's something which we are promoting in the context of the discussion of the smart specialization strategies for the future, is that our smart specialization strategies, our focus on industrial transition, have to address societal challenges as well as business objectives. And this means rethinking, in some cases, our smart specialization strategies. We need to strengthen this term is the entrepreneurial discovery process, but this means essentially making the priority setting process more dynamic and more living. This will need to be underpinned by policy intelligence and an upgrading of policy tools. And we need to think about how we support innovation ecosystems, and part of this will be monitoring and evaluation, and particularly to take into account these issues of industrial transition and the objectives that potentially we can set for this. So let me conclude by just outlining a little bit the next steps, what we are thinking about. So of course, the main focus for us at the moment is the preparation of the next generation of programs and the development of smart specialization for the next period. One of the key things that we want to promote is strengthening the evidence base on what works and what doesn't work, and in particularly in terms of designing our policy tools. We are currently finalizing the work on our interregional innovation investments, or component 5. In principle, we will be, together with DG Research, part of the new innovation agency on this, operating under Horizon rules. And I think this is a very exciting opportunity to focus on linkages as opposed to just place specific projects. We are reviewing the support from the Joint Research Centre and the experts we have provided for regions. I think we feel that we can, let's say, upgrade our efforts in the future. We recently published a report on this. We are also in the process of the just transition mechanism. We are responsible for developing a just transition platform, which will have the role of supporting regions and exchanging practices in the context of the Just Transition Fund. We continue our work with the OECD, and I just really wanted to highlight two of the strands of work which I think may be of interest to you. We have a project with them looking at innovation diffusions and bottlenecks and how this can be addressed. And this is very much about the configuration of actors at regional, sub-regional level, how different levels function together. And then another project which we are just starting, which we think is a potentially very important project, is because it will feed into the long-term vision of rural areas, which the Commission is preparing, is a project on industry in rural and peripheral areas, because there is a very, very strong focus on the one hand on agriculture and related activities, and really very, very much the primary sector, as opposed to processing and extractive industries, as well as other types of industry. And on the other hand, the idea that the interesting stuff on innovation and economic growth is taking place in cities. So I think the purpose of this project is really to better understand the opportunities there are for Europe, particularly in the context of the changes that we see, in terms of technologies, in terms of digitalization, in terms of the circular economy, in terms of value chains. And then finally, we're doing work with the World Bank on the monitoring and evaluation of smart specialization. So, you know, I've kind of given you a photo of where we are. We're very happy with the way in which the pilot action has worked. It really has been a very successful exercise. I just wanted to finish by taking the opportunity to thank everybody who has been involved in East North Finland for their investment in the exercise, which we think is, you know, as I've said, something which will really bear a lot of fruit in the future. So thank you.
Thank you very much, Peter. That certainly gave us a better picture what's going on, and thanks for the update for current situation from Commission side. Does anyone have a short comment? If I may, I can assure that East and North Finland will be definitely interested about the OECD cooperation going with the industry in rural and peripheral areas. And this is something we would like to follow and hear more about in case possible. This is something which fits to our standing point with the current implementation of smart specialization very well.
Yeah, so just to add, I mean, you know, some of the people probably who are involved in the project, because we're doing it not only with the regional development people, but also with the rural and extractive industries people. Yes. So I think you know that you've probably, you know, and in fact they're also involved in the northern sparsely populated areas. So I think certainly, you know, there are a lot of potential links there.
Okay, thank you very much. And we're all actively taking part in this NSPA cooperation, and we have people from EU Office of East and North Finland here present who are in the core of the work on a weekly basis. So this is great news for us. But apart from that, let's move on. We still have 3 projects left, and I ask you to be strict with the time. I will track on that. Vincent, you have a short question. Go ahead. In the meanwhile, we prepare.
Yes, thank you, Ilari. Thank you very much, Peter. A short question. You mentioned at the very end I3 component 5, so the component 5 rebaptized I3. Can we know, maybe can we have a bit more of information about that? How far you are, and what is the internal mechanics of this new support instrument? It will be cross-regional, but also only for international cross-regional collaboration, or also cross-regional within member states?
No, I mean, this is a whole other presentation, but so I'll be very brief. The first thing is that it is addressing a gap, and that gap is in relation to funding projects across countries, yeah, so between countries. So it will not be within country, yeah. So that's the first thing, and our view is that the within countries should be dealt with through the national programs. The second thing is that I mean, it now has an existence because it was confirmed as part of the MFF. The budget was reduced from 970 to 500 million, but you know, we still think that this is enough to do some interesting things with it. The Commission has proposed, as part of its proposals on the new agencies, that it is together with the EIC and the innovation ecosystems in the new innovation agency, and we are in discussion with DG Research about the setting up of this new agency, the staffing, etc., etc. So you know, it's 90% sure that it will be done this way. We have launched a consultation exercise on this, which I think runs until the end of until the end of September. The focus, and I mean, there's always a bit of a confusion about this, but the focus is very much on financing investments in a triple helix context across borders. So, it's not money for to finance research facilities. It is money to actually pay for investments. And the question of the priorities that we will have will have to be discussed. But we assume, certainly from the Commission side, it's going to be aligned with the with strategic priorities, potentially strategic value chains, possibly, I mean, I think this is interesting for you in this region, critical raw materials, strong focus on circular economy. And the last thing is that, we have these interregional pilot projects. That's been a successful exercise, and as a result, we decided when we just launched, and I think the call is coming to the end this week, offer 4 new interregional partnerships in relation to COVID, in relation to tourism, in relation to circular economy, and also hydrogen and fuel cells. So this is the sense in which it's going at the moment. But I mean, I suggest you take a look at the consultation exercise if you want a bit more information. Okay.
Okay. Thank you for both. It's good to hear also from I3, but unfortunately we really need to move fast forward now. I believe we have an intelligent biomass analyzer, IBA, Markku Tiitta, online. Do you hear us, Markku? Excellent. We can see your screen now. Can't hear your voice yet.
Yeah, now I think its microphone is on.
Yes,
can you hear me?
Yes, please go ahead. You're welcome.
Yes, thank you, Ilari. So, dear listeners, I would like to introduce our pilot project, IBA, Intelligent Biomass Analyzer.
Mark, we lost your voice again. I will. Now
okay, let's try again. Yeah,
yes.
I'm sorry. So the project partners were Puumit, Prometec Solutions, Kuopion Energia, Kainuun Voima, Torek, Luke, and University of Eastern Finland. Research partners were Luke and University of Eastern Finland. The project is based on the long-term cooperation with the research partners. The end users were Kuopion Energia, Kainuun Voima, and Torek, which uses torrefied pellets, which were also tested in the project. So I think there are 2 major challenges with the biofuel production. So you need to have representative sampling, and you've got to have a real-time measurement. I think both of these cases are very nicely improved in this ELMO project. So with IBA, you can have moisture and quality information for the whole supply chain instantly. You got better logistics and stock control. You can have energy savings, and of course, it's possible to have savings in laboratory work. And all this, I think, it improves the biomass applications compared to the fossil energy and fossil solutions. So in ELMO project, novel intelligent biomass analyzer is based on electrical impedance spectroscopy, and artificial intelligence was tested and further tailored with the Prometec Q-robots. Novel sensors were tested, and their feasibility for real-time monitoring was evaluated. So about work packages, package number 1, laboratory testing and evaluation. We started with from the laboratory. We had tests with our IBA system and the laboratory, and we modified the IBA systems to be able to use with the QRobot. We have laboratory tests, and that was done well. And after that, we integrated the system with the Prometec QRobot, and then we had industrial test from February 2020, and that was nicely done. We have also this networking part of this to find out potential end users and business partners, and we have now 2 future project plans for the future, and that was also nicely well done. And we also built a roadmap to be used for the plan of how to have a business from these systems, and it was also well done. Here's the Prometec QRobot truck sampler. So it takes 6 samples from the truck load when it goes to station. Indeed, the Prometec station is for the Kainuun Voima production energy plant, where all the biofuel comes. So we installed the IBA, and we have the multi-sensor setup. We have electrical impedance spectroscopy sensors and modules installed in the system, so there will be electrical fields inside the materials. Then we have infrared and thermistor sensors to measure temperature. We have also acoustic emission sensors, which were very useful for example in identification of the material. Then we have also laser to have a volume, and we have the scale system to measure the weight of the sample. So a couple of words about project progress. So at first laboratory analysis, then on February we put the system to work with the Prometec QRobot in the industrial environment. So we have about a little bit more than 10 times we went to the Prometec, and we tailored and updated our system, also software and hardware. And machine learning methods were used for the analysis, and we tested also continuous learning solutions. We had quite many meetings and visits with the project partners. We have also physical visits before the corona. So the results, I think with Prometec, we think that IBA robot system worked successfully with the Prometec robot, and we have this data collection in cloud, so we have real-time results from the measurements. The main determination is the moisture content, which is very important for the fuel. And we have also this classification system for materials. It can classify materials. Is it wood chips, or perhaps forest residuals, or perhaps wood dust, that type of thing. We have this studied the effect temperature. We also measured materials which are frozen. And all the time, the IBA measurements were compared to the reference moisture content, and this was done by Prometec Solutions OU. So I think we progress to the technology relevance level 7. So prototype was demonstrated in operational industrial environment. So this is just one calibration for wood chips. So the y-axis is the IBA measurements, and this real moisture is ice drying standard method. And for the future, I think, unfortunately for the project, but I think fortunately for many people, the last winter was not very cold, so we have to do more tests with the frozen materials, and we used continuous learning methods, but of course these are very challenging, so that's what we continue also, and also test other materials. And we have this future collaboration project in future. And here's, I hope we can see the video. So here's the Prometec testing site, which goes to the Kainuun Voima production plant. So truck comes in, Prometec robot takes 6 samples from the truck load, puts them to the tube, and there we have this IBA measurement, and we get moisture content, and we have spectrum, electrical spectrum, and it's right real time. You can have it on laboratory and or for the production chain. And when the trucks continues, I think we already got the information based on the new system. So I would like to very much thank you for the ELMO team and project partners for this. I think that's quite big leap towards commercial solution by having this ELMO project. Thank you.
Thank you very much, Markku. Happy to hear that you were also able to conduct the studies despite the situation with the COVID. So I suggest that we keep the questions and comments for all these 3 presentations after then. So let's move straight to the next one. We have Natsi. We have Kasperi Vuorikari from Nollasi company presenting the Natsi project. I will make Kasperi here as the presenter.
Hello, hello.
Hello. Now you should have the rights to present.
Yeah.
Yes, looks fine.
Yeah, let's have this. Okay, can you see this one?
Yes, we can see it.
Hello. Okay, good. Good afternoon or good morning, whatever. My name is Kasperi Vuorikari, and I'm from Nollasi Oy, and I'm here to present this NATC pilot, and NATC comes from nutrient carbon. The collaborators or the people, the companies that were working in this project were Nollasi, then VTT, and VTT is Finnish Technical Research Center of Finland. Then we had University of Eastern Finland and Navitas Kehitys. And from the company side, we had Stora Enso, a big, they have a big pulp mill in Varkaus. And then Saimaan Tuore, that's a local fish farm, also in Varkaus. And then Järvikylä is a greenhouse that's producing salads and herbs here in North Savo region. So these are the companies and entities that were involved in this project. The idea of NATC is that rather than taking all the industrial side streams from forest companies or from food manufacturing companies, rather than landfilling them or even burning them, we take the side streams and we process them and we produce something we call nutrient carbon. And in this way, we can bind the CO2 with plants rather than releasing the CO2 to the atmosphere from burning or landfilling. So this is a circular economy idea. And then let's see. The steps in this project were mainly concerned with VTT, and that the question was that is this feasible to do this kind of processing with side streams that are wet? And according to the and that was the goal of VTT, to make mass and energy calculations whether this can be done or not. Then Nolla and University of Eastern Finland and VTT, we're looking at some side stream processing technologies, and then also some pre-study of the process concept, material processing, and we also did a pre-feasibility study and a basic business plan for this whole thing with Navitas Kehitus, and Nolla was the project coordinator, and all the steps were done in successfully completed in this project. So from the VTT side, the conclusion was that there is the process of treating side streams is feasible in terms of mass and energy, and this was very important result because there was some doubts whether there is enough energy in the process, or whether we should have additional energy from the local power station or from Stora Enso power station. And so this was a very important result that it's feasible. But in addition to this result, it was also found out that the zero fiber or the side stream from the Stora Enso plant, it has to be pre-dried. It's so wet that there is a need for pre-drying, and the only way to have it feasible is that if the pre-drying is using secondary or waste heat from the power from the industry where it's located. And this question was also solved. So there is some waste heat from the Stora Enso's pulp mill which we can use. And now, so these two things about energy and drying are now in a way solved. VTT also made some, in addition to the calculations, they also made some pre-layouts or sketches what the whole thing could look like. This is one of the options which we could have, and this one was also very good to have, so that we could see the exact size of the plant and the space required for the next steps. And it turned out that the layout is very compact, and when we move forward, we don't need too much land for this unit. University of Eastern Finland did also a lot of research for us, and also analysis of the fibers and of the carbon. And here you can see on the left-hand side, you can see the same electronic microscope image of the carbon, which is, and then also some chemical analysis of the zero fiber, one of the raw materials we were using. So University of Eastern Finland, they had a good scientific contribution for the project. And since we are moving fast, final results. It can be said that with the mass and energy calculations, this process is possible to do, and drying is the key for the success. And for this reason, it's good that in this ELMO we also had drying industry involved, and I'm looking forward of cooperation with SF Tech, for example, in the future steps of this unit. Feasibility calculations prove that the process is feasible and economical when drying is done with waste heat. So there has to be a circular economy function in this one, and the unit wherever it shall be, it should be very close to the raw material or zero fiber producers, and it should also use the waste heat from that unit, whether it's a pulp mill or paper mill or whatever. The one big surprise we faced in this pilot was that the requirement and legislation concerning the operation of this kind of unit is not very straightforward. The idea is very new, also for the people in the environmental offices, and they don't exactly know whether we are a waste treatment plant or are we a fertilizer manufacturing plant. And for waste treatment, there's a different legislation and different set of permits you have to have, and for fertilizer manufacturer, there's a different set of permits and which you have to apply. So this is one of the things that came as a bit of surprise for us, that the legislation part is taking quite a long time, and first authorities, they have to decide what we are. Of course, we have also a saying in saying what we are, but then it's up to the authorities to say that, okay, you are either or, and then move forward with that kind of permits. And it seems that there needs to be, for example, environmental impact assessment done, even though we are working in an industrial area, and that also takes quite a lot of time and money. In addition to this, there is a need for a new product name or product category that must be applied from Ruokavirasto, that's the Finnish food authority, if the product is a fertilizer. So I could say that the math and energy and calculation engineering side is okay, but then the legislation side needs a bit of work, and that work takes usually quite a long time. But we are moving forward with this. We have filed an application for Ruokavirasto, and we are working with the environmental people, so that these are not problems that can be solved. There's a solution, but it takes time and money. But anyway, all in all, thank you for Lapinliitto and EU for the finance of the project. It's been very good and very important for us to find all the things we have done here. And without this kind of support, I think for a small startup like Nolla CO, it would be very difficult to do these things on our own. But with this finance, we have moved very quickly forward. Thank you, and if you have any questions, I'm happy to answer them.
Thank you very much, Kasperi. As I said previously, let's keep the questions marked down for after and present them after the next and the last presentation. It's good to hear that you found some interconnection with other projects. There are at least three projects related to drying of a biomass. Let's go forward. We have a Greenland platform for sustainable forestry, and I think Mikael Korkman from Fomatec is presenting how Fomatec and Funlus were able to proceed with their project.
Yeah, I can take presentation.
Yes, I will make you as a presenter. Yes, Markus.
Hello, Guy. Hello, all.
Yes, there you go, Markus.
Can you see the presentation?
Not yet. You have two screens, it might be in the other one, or should have the rights. Now it looks good.
Okay, great. So, hello everybody. I'm Markus from Funlas. Actually, we are the service provider on this Greenline platform for sustainability forest project. But Mikael Korkman from Fomatek can say if he wants something to say about it. But in this pilot, we have developed new platform, Greenline Digi solution, and we have also calculate carbon footprint and reach TRL level 8, I think, and this is very big project, and I think Mikael Korkman can say that this was very good project for all who attend this. But I can continue. Just maybe see the consortium. Fomatek was the lead partner, and we as Funlas was service provider. We developed this digital platform or app, and Motoajo was end user who test the app, and we have also Natural Resource Institute of Finland who developed the carbon footprint calculations and environmental impact analysis. And then we have University of Eastern Finland Digi Center who was advisor and test also this on more technical ways, like how much how many users it can take simultaneously to handle this server and usability they test, and yeah. But let's see what this app or digital platform is all about. Here is our model, Mikael Korkman, who have new unit to deliver it to stock. And Fomatek, for example, they have blades to harvesters, and it's circular economy operating. They have these blades. Mikael can tell more about it. But they load items to logging company stock, and then they can scan quick response code, QR code. You know all this QR code system. And then in mobile, you can just update the quantity. If you take some items from the stock, you can update it, or you can increase new items to stock. And it's real-time data. And this is very important from logging companies to know what they have in stock, and the system automatically fulfills the stock if the limit meet the limit what the company have decided. So it's very automatic system, and it also calculates carbon footprint for each delivery and so on. There is some screenshots from app. It's login screen, and you can scan the QR code. And there is client dashboard, order tracking, and carbon footprint reports. And this all is real-time data. And the point is that the logging companies can have this reports maybe on their website in the future that they have saved that much carbon footprint, or yeah. We have gathered feedback and we have made this.
Sorry, Marcus, we haven't seen any slides changes, so maybe you're on a different slide that we are following. We are still on the first one.
Okay, sorry.
Maybe
how is that possible?
You see the arrows there down below. You can put forward from there, at least on the right hand side. Yes, now, okay, these were the screen captures.
Yeah, this is, sorry. Well, maybe this is something. Can you see now?
Yes, go ahead.
Oh, okay, so this was the Mikael Korkman deliverance talk. And can you see the dashboard screenshots?
Yes, we can. You can move forward.
Yes, and this was the feedback slides, and also
we're still on the user interface slide number 4.
Okay, how this? Maybe I turn off my microphone. Future plans.
Okay.
Okay, the future plans. New business opportunities discovered. Next step, maybe in the future, implement road optimization, and there is also possibility for internationalization for this app, and also Fomatec is finding solution for emission trading or compensation, and that's the next steps maybe go to if we get funding for that, and looking forward. Thank you for this presentation.
Thank you very much, Marcus. Before we go to the questions and discussions, do we have still Peter on the line? I know that you have to rush the next meeting, but maybe a final word for you at this point.
Well, Hilary, thank you. I mean, it's been very inspiring to hear these presentations, because one launches these pilots and you never know quite what will come out of them. And I'd really just, I mean, I don't have so much comments on the technical side of these projects, but I just wanted to say that they respond very much to the changing policy objectives we have, and I think that I really just wanted to leave with that positive message. And I mentioned in my presentation 3 things, and I think that one of the challenges for the regional authorities in East and North Finland will be to see how you can build on these. So I just wanted to pass these, these 3 big policy objectives at the end. The first, of course, is the Green Deal, and this is delivering climate neutrality but reinforcing the circular economy. And I think that all of these projects have offered different ways of doing it. The second thing is the development of value chains, and I think the specific focus that you've had in your region on building links within, even at municipality level, and building upwards is a very, very important part of this, because it's a platform to launch into bigger European value chains, and particularly in the demand for new and innovative materials that will be needed in the coming years. And the last issue is you kind of responded to this, is this reflection on industry in rural areas. We're in a reflection in Europe about how we reinvent our industrial base. And I think we feel that rural areas and peripheral areas potentially can play a very, very important role in this. And we've seen, with these projects, the way in which building on the resources of particular areas, you can produce products which offer the opportunity to create economic activity and employment, and as I said before, fit into the transformation of value chains in Europe. So I think it's been very, very positive. Of course, the interesting question is, where do you go to from here? So thank you very much.
Thank you very much, Peter. If anyone has now a brief comment for the past 3 presentations, I will have a moment for that now until we move to the last speakers before finalizing. If not, you're free to also write it on the chat, and we can also connect you with the pilots and continue the discussion further on after this on other platforms. I think it's now time to give the floor to Vincent. If you take briefly minute or 2 just to conclude from your side, and then we move on with Mika and finalize the event. I'm sorry about the tight schedule.
Yes, well, do you hear me, Hilary?
Yes.
Colleagues? Okay. Well, thank you very much. I will try to be brief. It's very, very interesting. It's really extremely interesting to see the progress that has been done over the past month, and basically in a Corona era, which is not the ideal one, even not in Finland. But in a short period of time, you were all able to reach to make quite some progress, I must say. I think that what I heard today, I would say mainly 2 things. On the one hand, everybody was very positive about ELMO, about this high impact action. I have heard things like it was very easy, low administrative burden. So it's a kind of very agile instrument that has been developed to do the job that we wanted that instrument do. Mainly help companies and research center, technology center move forward beyond TRL5 towards full commercialization. I think it has also succeeded at filling a gap in the policy mix, in the Finnish policy mix, and in the regions of East and North Finland. By doing so, by providing the opportunity to companies and research centers, technology centers, to further test prototypes and integrate systems and subsystems with each other, or on a digital platform, for instance. And so my first reaction is indeed, as Peter said, how will it continue? And a first reaction to the policymakers, the Finnish policymakers, will this induce a permanent change in the policy mix in your regions? Does that mean that this exercise will be continued over the next month and years? Do you have the right instruments to further help companies and innovators for the next steps? So that's an important first question to think about. The second thing that I heard today is that everybody progressed, but at the same time, there are quite some differences in maturity levels. And you can say almost everybody would need additional testing, additional technical testing. I would say this is the case for Plainwood, for Ops, IBA, for instance. At the same time, we heard also some further steps needed for certification. I think of Nutrient Carbon, for instance, Nutrient Carbon project, where the environmental permit and certification of new soil fertilizers are an issue as well. So it is not only support for further technical testing, it is also support for certification and legislation, actually, legal steps. And we heard also something else, which is support for a larger deployment and release scalability to get scale effects. And I'm thinking of wood heat, for instance, where here the next steps are more helping basically a company and technology centers to move beyond TRL 8 actually and set up a fully operational pilot line, first of its kind, with integrating operators at municipality level, for instance. This is what we are speaking about. So these are totally different needs, and then you need to think about that, how to cope with these different needs, at Finnish and at regional level. And finally, I would like to end with a final comment. There is also quite some synergies between projects. You said a little bit, you pointed at that a few minutes ago, Hilary. But clearly, I see some clear synergies between wood heat, IBA, and nutrient carbon. So the or the drying of the biomass is an issue for different of those projects, and maybe we could think of integrating in one way or another these three projects maybe for a European project, or for an international project in the context of the Arctic Investment Platform, for instance. Because these are, drying biomass and valorizing side stream from forestry-based value chain is something that is impacting Sweden and Norway as well. So maybe we can think a bit in that direction too. But as a conclusion, extremely impressed by the progress you made in such a short period of time, less than 6 months actually. So congratulations to everybody, and let's now think further about the next steps and how to further support these projects. Thank you very much.
Thank you very much. Excellent conclusion from Vincent. Mika, do you still have some time for the last comment? Thanks for staying on the line.
Yes, thank you, Hilary. I'm still here and I have time. So maybe for final words for me, I've been partly listening and it has been very interesting to hear about the conclusions for all these projects. But from my perspective, as Peter told, the world looked many ways different 1.5 years ago when we started this process. And same time, I totally agree what Peter said, that actually now more than ever we need new ways to seek sustainable growth and innovations all over the Europe in order to recover from the situation that we've been facing. So although the world has changed more quicker than we've been waiting, we are still in the nick of time when we talk about the goal of this process. 1.5 years ago, when we got the pilot status, the Eastern Northern Finland, and when we start this pilot, this high impact action, I believe that we saw in all regions this as a positive challenge. and positive challenge from two perspectives. One was, of course, the challenge of technical and sort of a bureaucratical implementation of this funding mechanism. And then, of course, the challenge to interregional implementation, sort of a test for collaboration of 7 regions. And I was very positive and a little bit surprised that actually the technical and bureaucratical implementation was actually the bigger challenge. I didn't see the collaboration phase at any amount of that kind of challenge that we faced in the bureaucratical implementation. But both challenges we faced, and I believe that we also were very successful. But if we go to the background and the goal of this high impact action, actually it was very simple. It was combining the strengths of 7 very sparsely populated regions, their innovation capacity, their research capacity, and putting them into use of SMEs who has a growth potential, and of course in the context of industrial transition. And when I think that the situation now and all these results that we have here today, I think that this pilot has shown that it is possible, and doing things together, actually we can add value to all of our regions, and most important, to our companies all over the East and North Finland. Finally, I'd like to highlight that this has been also a very good learning process for all of us. And from a regional perspective, I believe that now we are more ready to make this kind of cooperation. I believe that we've been showing to ourselves that we can do this kind of transition policy into and change it into pragmatic action. And also, I think that what Peter told, this has been also a learning process for Commission. And then when we are facing the preparation to new programming period, I sincerely hope and believe that we can utilize these experiences when we plan the new, more effective tools to sustainable growth, and of course to find new ways to recover this situation, economical situation that we are facing just right now. And as Ilari told earlier, from a regional perspective, we all 7 regions here in the East and North Finland, we are ready to collaborate more and also participate actively to this common goal for all Europe to make sustainable growth. So finally, I'd like to thank all of you who have been part of this. Of course, the Commission about launching this and giving this possibility to us, evaluators, all the officials, all the 7 regions that has been active in this process, and of course especially the companies and research and innovation professionals all over the 7 regions. I was especially happy to hear that all of those projects, they have been very successful, and I sincerely hope that we will hear a little bit more about what will happen, how they can develop more and have a more successful business possibilities. So once again, thank you all.
Thank you very much, Mika, and thank you for the companies also joining today and presenting presenting and using your valuable time for this. And I would also like to extend thanks to our colleagues Päivi and Olli and Paula, who's been working very hard on this high impact action since the beginning and making it possible, and also our task force colleagues in other regions of East and North Finland. Big thanks for you, especially for the communication efforts we've been having, get these people together and listening and learning from each other. Now is the time to close this session. I'm sorry that we exceeded the time a bit, but this will be recorded, as I made the point in the beginning, and you can all listen it later. And let's keep in touch with the projects, and thanks a lot once again. Have a good day.
Thank you, Ilari. Thank you, everyone.
Thank you, everybody, and a lot of success with the next steps. Bye-bye.
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 Thank you. Bye.
Bye.